Um, I see we have some friends on. I know a lot of people are going to be watching at home. Hi, everybody. I hope you're staying safe. Today, I wanted to take a look at the way that scientists like to ask questions. I know that a lot of us in our classes are talking about Earth Day. Who's talking about Earth Day in their class? Are you talking about the Earth? Yep, some of my friends are. Has anyone started talking about Israel yet? It's Israel's birthday next week. It's going to be Yom Ha'atzmaut. And so I wanted to make something today over video chat with you guys. And we can make it blue for Yom Ha'atzmaut to celebrate Israel. But really, I wanted to look at the way that scientists get to ask questions. So let me see if I can share with you guys what I'm looking at my computer screen. Give me a thumbs up if you can see this, if something new popped up on your screen. Something new pop up? Love that. My friends, we are going to make Yom Ha'atzmaut Play-Doh today. First, scientists always start with asking a question. Anyone notice that symbol in the middle? That's a question mark, right? It's a symbol that we use when we want to ask a question about something, when we want to know something more. The question that I wanted to ask is why, when I made my yellow Play-Doh for when we went to Explorers to Italy, why when I made it, it was so grainy. There were lots of little pieces in it, and it wasn't very smooth. And I want to know if there's a better way to make Play-Doh where it becomes more smooth. The way that I made it, which some of you guys make in your classes, is we add hot water to all of our ingredients, our flour, our salt, our cream of tartar, and they add hot water. That's what I did here, but it made it very, very grainy. You could really feel all the little salt in it. So my question that I'm going to be asking is there a better way to make Play-Doh where it comes out more smooth to the touch? Because we really want to pay attention to how things are feeling. And I like my Play-Doh smooth, so everybody is different. So that's the question. First, we always start with the question that we're asking. Next, I'm going to make some observations. Observations are like what these kids in the pictures are doing. They're looking really closely. They're using binoculars and magnifying glasses to look and make observations about it. So I'm going to look at my Play-Doh. Let's see if you can look at it with me. If I break it apart, you could see all the little pieces that are inside of it. It's not very smooth. It gets very dry. I'm using lots of different words to describe what I'm seeing, because in science, you have to be very specific and you have to use lots of details. So I'm making lots of observations about what in my Play-Doh I do not like. I do not like that it's not very smooth. I do not like that it's bumpy. I notice that it's very dry. And I'm observing that it looks really different than the way that I want it to. The next part of what we're going to do to ask a question in science and find our solution is we're going to make something called a hypothesis. A hypothesis is like our guess. It's what we think is going to happen. I used to make Play-Doh, like when I made this one, right, by pouring the hot water over all of the ingredients. My hypothesis, my guess for today, is that my Play-Doh, if I make it cooking it like on the stove, like I'm cooking soup, that maybe making it that way will come out with smoother Play-Doh. So that's my guess. My guess is that doing it in a different way, trying to really cook with it over the stove. Does anyone here have a kitchen at their house? Who here's got a kitchen with a stove where people cook? Amelia's got a kitchen with a stove. I know April's got one. So I too have a kitchen with a stove. My hypothesis, my guess of what's going to happen is that if I cook my Play-Doh, instead of pouring hot water, if I cook it like I'm really making food, maybe it will come out more smooth than it did before. And the next part is the exciting part. We get to experiment and test our hypothesis. Look at these friends in the picture, they were really looking close and they're measuring things. So I'm gonna have you guys help me measure. I have my ingredients list that tells me how much of everything I need. And whenever I get out a material in science, we try to make observations, right? Like how we were observing before. We look at details. I'm gonna look at my flour, my 1 cup of flour, and I notice that it's very powdery and it's very soft when I touch it. And it's okay to get messy, right? Because sometimes we do science experiments and they get a little bit messy, but that's okay too. We can always clean and we always help to keep our world clean, right? Tikkun olam, taking care of our world. I have my flour inside, and now I'm putting salt inside. Again, I'm gonna feel it and think about how it feels and the words I would use to describe it. I think the salt is very grainy. The salt is very bumpy. It's, if I taste it, it's gonna be pretty salty. I'm gonna mix my flour and my salt and my secret ingredient, cream of tartar, which looks white, a little bit like flour, and it's still soft to the touch. And we're not, as you see, I'm using a tiny spoon. Before I was using the bigger one, the 1 cup. And now I'm using a teaspoon, a tiny spoon, to put my cream of tartar with all of my other ingredients. This is still part of the experiment where we're testing the hypothesis, right? Our hypothesis is that cooking Play-Doh, like you're cooking soup, is gonna come out with very smooth Play-Doh. So we're gonna see if that's how it really works. Because we're doing Yom HaAtzmaut Play-Doh for Israel, anyone know the colors on the Israeli flag? I don't know, you could scream it. What are the colors on the Israeli flag? Anyone know? Scream it. Did I hear anyone? Oh, blue and white. I thought that I heard somebody. So I'm choosing blue to use for our Play-Doh today so that I can play with it. And maybe I can make an Israeli flag with it. Maybe I'm going to make a Jewish star with it. I put water in my cup and I'm putting blue food coloring. And I add that. And let me show this to you guys so you can see. Now, all of my ingredients are together in my pot. Blue, and there's the flour, and there's the water, and I'm gonna mix it really, really fast. And it's over the stove top. Does anybody know stovetop? Do you think that that's gonna get things hot, or do you think it's gonna get things cold? Any guesses? When I cook something over the stove, I'm adding fire to it. I'm turning the fire on. So you have to be careful. And if we're making Play-Doh this way with a grown-up, you can always ask a grown-up for help. So I'm mixing, and I turn the fire on. Right? A lot of times when we see fire like on a candle, it's yellow or it's red, but at the bottom there's blue. The blue part is the hottest part of the fire. So I turn the fire on, and we're gonna cook the Play-Doh inside the blue. Mix the flour and all of the ingredients together. And last time I took hot water and I poured it over my ingredients. This time I'm cooking it all together. So I'm hoping that this time my Play-Doh will come out more smoothly. That's my hypothesis. We always have to think about what is our hypothesis? What are we trying to figure out? We're trying to figure out a way to get smooth Play-Doh. Because the way that I did it before, it didn't come out the way that I thought. So we keep on stirring, and when we add the heat and the fire to the water that's inside of our pan, it's going to evaporate. The water is going to go up into the air. And it will make you'll see the Play-Doh will get very thick. It's starting to get thick, like how we said Play-Doh. Once it's ready, I can take this off and show you. And we can see our experiment worked. Because now we're doing the experiment portion. Oh, I'm going to turn my heat off and bring you guys over here so we can see the Play-Doh and see if it worked. Oh, check it out. Blue Play-Doh. I'm going to feel it with my hands. Oh, and it's so much smoother than the yellow one. Oh, look at that. Let's see. My Play-Doh worked. Let's see. I can show you the last part of what we do for science. Here. Thumbs up if you could see something. Can you see the screen? So we did our experiment, and now we get to analyze our results. We get to see if it worked. So I'm making more observations. I'm looking at what happened in our experiment, and I'm thinking, well, maybe because I cooked it this way, maybe the heat from the stove is what cooked the salt more. Maybe that's what made it more smooth. Maybe it's mixing everything together at first instead of mixing everything one thing at a time. But I'm looking at my results. My result is my Play-Doh. That's what I was making. And I'm analyzing it by looking at it and seeing if it's giving me what I wanted. Did it give me the smooth Play-Doh that I was looking for? My conclusion, the last thing that scientists do when we're looking at all the different steps to asking a question and answering it, the last part is making a conclusion. Being able to say, did it work or did it not work? And I think that the way that we used today for making Play-Doh, cooking it on the stove, really works, in my opinion, better than the other way. So, oh, here we go. So we can see that trying to ask a question takes lots of steps before you can actually get your answer. We need to ask our question. We then looked and observed at the original Play-Doh, the yellow one, and we made observations about it and tried to tell what we were trying to fix. We had to determine what our experiment was going to be, the way that we were going to change making our Play-Doh, and make sure that we asked our hypothesis. We gave our guess about what we thought was going to happen. Our hypothesis, right, was that the Play-Doh would come out more smoothly if we cooked it this way. And our hypothesis was right. It's a very big word. And then we were able to analyze the results. We get to look at what happened and make a conclusion about whether it worked or not. That whole process, the step-by-step process of asking questions and finding out the answers, is called the scientific method. It's a super important thing for scientists. Whenever they ask questions, they have to ask it in a certain order to make sure that all of the questions are being asked and that all the information is there. And that way you know what you're looking for. And you could tell whether your experiment worked or not. Has anyone here ever made Play-Doh before? Raise your hand. Anyone here ever made Play-Doh before? Matthias has made Play-Doh. I know we've made Play-Doh in class before. Maybe in messy art class with Angelina, you've made Play-Doh, or at your houses. And there's different ways of doing it. So we can experiment by trying different ways of making Play-Doh and seeing which way worked best. There's another way where you can make it in the microwave. Maybe you could experiment and try doing it that way. And you can compare, have the Play-Doh that you made on the stovetop and the Play-Doh that you made in the microwave and the Play-Doh that you made with hot water all next to each other, and make observations and analyze what the Play-Dohs look like, why they might be different, and which way was the best way to do it. And make a hypothesis, what you think works best, and then you do your experiments and see what happens. That's one way that you can do it at home. And I can send Play-Doh recipes if you guys want to do this at home. And I'm going to use my blue Play-Doh to make an Israeli flag for Yom Ha'atzmaut next week. We're going to celebrate together. Who here is going to celebrate Yom Ha'atzmaut with their friends on Zoom? My friends are. We're going to do a whole week of learning about Israel. I hope you guys will get to do it too. And I hope at home you can do some kind of science experiments, ask lots of questions, and see if there's ways to find out answers to your questions. Using the scientific method, all these different steps that scientists take in order to get answers. Yeah. Does anyone have questions? Amelia, should I send you guys all the Play-Doh recipes so you guys can make this? And then you guys can try it a different way. You can make a hypothesis, what you think is gonna happen. Maybe your hypothesis is that it's not gonna work on the stove. Maybe that's your hypothesis, what you think is gonna happen. So you get to make your own guesses, and then you get to do an experiment and see what happens. I love that. Anyone have any questions? No, Matthias, I see you going no. Oh, Amelia, yeah, what's up, love?
How much times have you made Play-Doh?
I've made Play-Doh maybe 30 or 35 times. So that's lots of times, but I've never done it this way, cooking it on the stovetop, like in my kitchen. Never done it that way. So I had to follow all the steps of my scientific method to see if it would work. I had to ask the question, figure out my method, and then test it and see if it worked, because this was new for me. Never tried it this way, and it worked very well. I'll send you the recipe. You guys can do it at home. Love that. That was a good question. Any other questions before we end? Because I know that you guys maybe can take a few minutes and go to the bathroom and get a snack or some water before we have our next Explorers class. There's another Explorers class next. I'm not sure which one is next, but we're gonna find out. It's gonna be a surprise. I'm very excited about it. And this was a lot of fun. Who had fun doing science with me? Yeah, love it. Guys, I'll be back for science next week, where we're gonna make a super special maze that goes on your wall, like a marble maze. It's gonna be very exciting. Start collecting paper towel rolls and toilet paper rolls if you can, and maybe you can make it with me. And we're gonna do that next week on science, STEM with Tatiana. Hi, Asher. My friends, I hope you have so much fun in all of your enrichments this afternoon. Have a good time with all of the teachers. Go to the bathroom, go get some water before you come back and hang out with us all afternoon.
Thank you, Tatiana. That was so fun.